Hi, I'm Mrs. McTaggart and this is video number 5 in the higher vector lessons, and it's called the scalar product, also known as dot product for short sometimes. So this box in the middle shows you two formula that are given to you on the formula sheet, so you don't need to memorise them. You just need to know how to use them. So a bit like, let's go back to maybe gradient in National 5. You get taught two different formulas for gradient. You get taught vertical over horizontal, and then if it's an actual coordinate question, you get taught the y2 minus y1 method. Kind of along the same lines here, there are two different methods of doing the scalar product. So the two formulas you have here, a dot b equals x1 x2 multiplied plus y1 y2 multiplied plus z1 z2 multiplied. So that's this first one here. The other one you have is a dot b equals magnitude a times magnitude b cos theta. Okay, so it's kind of reminiscent a wee bit of maybe one of your trig formulas back when you did that 5 triangular trig. So just to remind you, the product of two numbers is the value you get when you're multiplying. Kids forget the product of two numbers from day what? Day dot. So it's all about multiplying, and you need to be able to do this to find the angle between two vectors, which is the next lesson. So just a little reminder, this Greek letter is theta. It stands for the angle between the two vectors. Theta will always lie in the range of 0 to pi, which is 0 to 180. Just one little thing to point out to you is my little diagram here. Both vectors must be pointing either tail to tail or head to head. That means both pointing away from your angle or both pointing into the angle to work. This is the most common scenario in my picture here, where they're both pointing away like that. If you have the scenario that maybe one of them aren't both pointing the other way, we have to do something else to do with extending our lines and making some 180 degree lines, okay? But we'll see more of that in some of my examples. Let's get to it. Here's question 1. So we're simply asked to find a dot b, and we're given two vectors. So you look up your formula sheet. This one has no mentions of angles, so this is going to be using the first one we gave you. So this is going to use a dot b equals x1, x2. It doesn't look much like an x. X2 plus y1, y2 plus z1, z2. So these just stand for, remember this is your x, your y and your z. So literally what you do here is you multiply your numbers. So you multiply your x's, so we've got 1 times 2 plus, then you multiply your y's. So we've got 0 times negative 1, and then you've got your negative 3 times your 5. So negative 3 times 5. And I just write it with brackets, particularly with all these negatives going on. Then you multiply it and work out what they are. So 1 times 2 is 2. 0 times anything is 0. And the last one gives us negative 15. So when you work that out, you have negative 13. So a dot b at this point is just negative 13, and we're happy with that numerical value. So that is style 1. Okay. Okay, notice in this one, it's not just like a dot b anymore, it's ap dot aq. Now, first thing to check is, are my arrows going the right way? Yes, they are. My arrows are going from a to p, and they're going from a to q. If they weren't, we have to maybe do something else, but they are okay here. So we're going to find a to p in terms of position vector first of all. So a to p will be little p minus little a. Now, that would be 5 minus 1, 3. Subtract minus 1 to 0. Okay, so 5 minus minus 1 is 6, minus 1 minus 2 is minus 3, and 3 minus 0 is, I wrote the wrong thing there, is just 3. So there's a to p. I'm going to do the same and get a to q now. So a to q will be q minus a, which will be 1, 3, 4. Take away minus 1 to 0. I don't have enough room, so I'm going to come left this time. 1 minus minus 1 is 1 add 1, so 2. 3 take away 2 is 1. 4 take away 0 is 4. So now I have my two vectors, AP and AQ. I can go do the actual scalar product. So A to P dot A to Q is simply the one, remember we've got x1, x2 plus y1, y2 plus z1, z2. So we're going to take our first numbers. So we've got 6 and 2, so 6 times 2. Then we're going to take our second numbers. So I'm just taking these to show you where they're coming from. I'm taking these two numbers next, so I've got 2 times 1, so 2 times 1, and then for my z's I have got 3 times 4, so plus 3 times 4, squeezed in there. So this gives me 12 plus 2 plus 12, which gives me 26. So the value of AP.AQ is 26. Okay, so that's that style. Example 3, this time I've told us that A dot B equals 0. So I've told you what A dot P should be, and there's obviously an unknown value in here. So A dot B would be P times P, I'm not writing the formula this time, so it would be P times P plus 2 times negative 1 plus 1 times P. Now we're told A dot B equals 0, so we can put this all equal to 0. So we're going to have P squared take away 2 plus P. Now if we play around with this and just rearrange it, I'm going to put my 0 to this side. Notice you've just got a trinomial. So 2 brackets, we're looking for numbers that multiply to 2 and add to 1, so it's definitely 2 and 1. Positive 2 take away 1. So my two options are P equals 1 or P equals negative 2. Two solutions. And both of those answers are okay because they haven't told us anything about P. Had it maybe said up the top that P is greater than 0, I could rule one out, but it didn't say that. So there are 2 possible values of P going on here. Okay, now the next 2 examples look a bit different. They've got mentions of angles. So the minute there's mentions of angles, you have to use the other version of the scalar product formula that was on the formula sheet. So that was the one where you have A dot B equals magnitude A, magnitude B, cos theta. Okay, so what we know is we already know in this one what magnitude A and B are, and the theta, the angle is 60. Now just a little reminder that on these ones you have to make sure that your arrows are both pointing both out the way or both in the way. So this one's good to go. So it's just a case of plugging in magnitude of A, which we've been told in the question is 5, times the magnitude of B, which is 4, and then we're going to times that by cos of 60. Now this gives us 20 times cos 60, you should know from your exact values, is 1/2. So you've got 20 times 1/2, so the answer is just 10 in this case. A dot B equals 10. So the minute there's angles and lengths involved, we use this formula now. So here is another one. This time I'm told that magnitude A and B are both 3. But notice the arrows this time. The arrows do not both point into the middle or both point out. So what we do is we're going to continue this A line and we're going to draw vector A over here instead, pointing out. Now that changes what my angle is going to be. The angle I'm going to be using is actually 30. So this is one to watch out for. If you accidentally use 50, it's not going to work. So the arrows need to be pointing both out the way or both in the way. So this one would just be A dot B equals magnitude A, so that's just 3. Magnitude B is also 3, and we times that by cos of 30. So this gives us 9 times cos of 30 is root 3 over 2. Whoops a daisy. So this would just be 9 root 3 over 2 for our final answer. Okay, and for my final example, this is another one that's going to use the second formula. So in terms of U dot V, if I adapt my formula, it would be U dot V equals magnitude U, magnitude V, oops a daisy, cos theta. Okay, now we don't actually have the magnitude of U or V yet, so we're going to have to go do that individually. So remember, the magnitude of U is just the square root of -1 squared plus 2 squared plus 2 squared, which will be the square root of 1 plus 4, which is the square root of 9, which is 3. The magnitude of V will be the square root of 4 squared plus 0 squared plus 3 squared, which will be the square root of 16 plus 0 plus 9, which is 25. And we all know the square root of 25 is just 5. So now I can go do the substitution. So we have U is 3, V is 5, and it will be cos of 80. Now cos of 80 is not our exact value. I also didn't mention I should have checked that my numbers were working okay. So this is one where you would be allowed a calculator. So you can go to a calculator and just type that in. And we get the answer of 2.60, so I'm just going to leave it as 2.6 for this one. Okay, so that is basically the scalar product for now. You'll use all these little bits a lot more in the next video when you go to find the angle between two vectors. Thanks for watching, bye bye.